Hi everyone, my name is Zeynep. I'm a final year PhD student from Singapore University of Technology and Design. In this presentation, I will be talking about our study on user perceptions and adoption of plug load management systems in the workplace. To start with the definitions of plug loads, they refer to any kind of electrical devices that can be found in workplaces such as laptops, desktops, and monitors. Today, plug loads contribute 1/3 of the total consumption in commercial places. This is equal to 50 million kilowatt-hour per year. Based on a recent energy report released in the US, more than 50% of the office users do not switch off their plug loads at the end of the day. That results in an estimated cost of $2.8 billion every year. Fortunately, in order to reduce this consumption, plug load management systems were proposed as a promising solution. These systems allow users to monitor their energy consumption in real time, provide interesting energy visuals through energy dashboards, as well as control their devices in an automated fashion. In residential spaces, these systems are often known as smart homes, as you might be more familiar with. A few government field studies investigated the effect of these systems in the workplace, but reported poor results due to low adoption rates. Given that the workplace users do not bear the cost of their own energy consumption, this makes system adoption a more challenging problem compared to residential spaces due to their lack of motivation. With this in mind, the question we investigated in this study is, how can we design future plug load management systems to increase user engagement and adoption rates in the workplace? To find an answer to this question and understand user perceptions on plug load management systems, we conducted a two-stage data collection approach, starting with focus group discussions, followed by online surveys. In total, we reached out to 101 office occupants from different age groups, gender, industry sectors, and knowledge on smart energy management systems, as you can see in Table 1. The main sections covered in both of these data collection approaches were participants' current plug load management habits, general perceptions of plug load management systems, ideal features, as well as concerns and motivations. Based on the quantitative data we obtained, our first key finding highlighted that 83% of the occupants lack motivation and they find it troublesome to manage their plug loads energy consumption in the workplace. When they are further asked what would motivate them to do so, top 3 choices were related to company influence, such as penalties, policies, and monetary incentives. On the other hand, eco-feedback, normative messaging, and competition with peers were found to be less popular. When participants were asked about the possibility of automating of their plug loads, 78 of the participants were receptive to the idea but were concerned about losing the control of their critical devices. These are laptops and mostly their desktops. This finding led us to conclude that users still want to be in charge of their plug loads even when automation is in place. When we asked participants about their ideal attributes and concerns on the use of plug load management systems, we found that the most ideal attributes include a system that is easy to use, allows for user control, and can be easily integrated with other building systems. Similarly, the biggest concerns are related to system reliability, convenience, and losing control of the critical devices. If we look at these 6 design implications, together with their high-level codes, the first one is external and internal influence, which suggests to supplement the technology with organizational policies and workflows to demonstrate company support. For reliability, it is important to prioritize features that affect the operation of critical devices and introduce a mode of recovery in case of a system failure. When it comes to user control, the system should empower users to have more control over its operations and enable customization. Ease of use indicates that the system should be intuitive and simple for system users. Furthermore, user appeal recommends the introduction of incentives and penalties to encourage long-term adoption. Finally, the design implication on privacy suggests the encryption and anonymization of the user's data to minimize data leakage. That's all for this presentation. Thank you so much for your attention. If you want to know more about this work, you can check out our research poster above. Hope to see you at the virtual event. Have a good day.